All right, we're back. We're still on page 2 of notes 20 of Calc AB. We're talking about areas of regions bounded by curves. And it's really just fundamental theorem, and you just have to make sure that you are setting it up correctly. It usually involves drawing a graph that is accurate, not perfect, but accurate. Finding some intersections if you need to. It's like a lot of algebra type stuff, to be honest, and then a little bit of calculus, namely the fundamental theorem. So let's see what we got here. We got y equals x squared, y equals 2x. So let's draw those on the same set of axes. Again, it doesn't need to be perfect, just needs to be good enough to get the idea. I don't know if I'm telling you that or if I'm telling me that. One thing that I find a little surprising, and I think other people maybe do as well, is that linear functions, because we tend to deal with them on like the interval from like, I don't know, 0 to something, like a very small boundary. The linear functions tend to be above higher powered polynomials. I think that's a little weird, but it's just the way it is, right? So I need to find where these intersect. You can just guess that it's going to be at 0 and 2, but I think I should show the work anyway. So 2x equals x squared. So x squared minus 2x equals 0, x minus 2 equals 0. So either x is 0 or x is 2. So this point is 2, and then 4. So that's our point. So the region that we're finding is this. So we need to know the top curve is y equals 2x, and that the bottom curve is y equals x squared. Set it up and solve it. That's it. So it's going to be the integral from 0 to 2. Top is 2x, bottom is x squared, dx. X squared minus 1/3 x cubed 0 to 2. So that's going to be, we plug in 2, we get 4 minus 8/3. Plug in 0, we just get 0. So 12/3 minus 8/3 is 4/3. I don't even feel like I need to check that. I'm just going to go with it. I think that's right. I think that's a very straightforward problem. Notice we weren't given bounds, right? So in previous problems, we were given the boundaries, right? Like negative pi over 4 to pi over 4. 1/4 was kind of arbitrary. Here it's like, it's not really arbitrary. It's just like, how would you know what the region should be? Because if you just said the region bounded by like these, there's two. There'd be this and this. So we had to be told some boundaries. Here we weren't, because these curves collectively only fully enclose one region. And so it was pretty clear. Let's take a look at this. Like what is even happening here? All right. So problem number 1 is I don't exactly know what this looks like. So if it's a non-calculator problem, I gotta like work some things out. I'm gonna pretend it's non-calculator and show you what I would do in that event. So, I mean, I know I'm gonna have to graph. I know what 2 times the absolute value of x looks like, and so that's good. So 2 times the absolute value of x is like, boom, and then where are you going? And then boom. Okay, so that's 2 times the absolute value of x. So far, so good. I don't know what this thing looks like, but I do know that e to the x squared is always positive. So e to the x squared is always positive. So e to the x squared is greater than 0. So then the sign of x times e to the x squared is going to wholly depend on x. So when x is less than 0, x times e to the x squared is going to be x times e to the x squared is going to be negative. Also, you can think about limits like as x goes to negative infinity, e to the negative x squared is also going to go to infinity, I guess. Right? Because you're squaring it, so you get e to the infinity. That goes to infinity. But then there's the negative. So like, I don't know. It's like down here somewhere or whatever. And then 0, you're definitely 0. And then I mean, it's gonna increase. So like, there's some place that they hit each other. Where would that be? I don't know. Can we like work it out potentially? Maybe. All right, let's see. So it's a garbage drawing, but I'm pretty sure that this is it. So I think there's 2 things you can say. You can say that the top curve on the region is 2 times the absolute value of x, but since the region only exists, So the region exists for x greater than 0. Therefore, 2 times the absolute value of x is actually just 2x. So I'm going to say the top curve is 2x. Y equals 2x. And then that would make the bottom curve this other thing, the one that I'm the most worried about, x e to the x squared. What you know what you can do is you can, so this is actually a really good tip. If you think you've done top takeaway bottom and you think you've done fundamental theorem correctly and your answer is negative, it means you did not do top takeaway bottom correctly and you need to flip your bottom and your top curves. I don't think that's going to happen to me here, but it might. Do these intersect in a nice place? 2x minus x equals, well, yeah, equals x e to the x squared, but like subtract from both sides. It's like, where do they intersect? You got x, you get 2 minus e to the x squared is 0. Oof. So you get x equals 0, or you get e to the x squared equals 2, which means x, I'm taking natural logs, natural log of 2. So x is either plus or minus, but we only need the positive. Because the negative one is what? Extraneous, I guess? Oh, no. So y equals 2x would intersect again, but we're not actually dealing with that. We're actually dealing with the absolute value. So that's why I'm taking the positive square root. Wow. Okay. Let's set up our integral. So it's going to be the integral from 0 square root of natural log of 2. That's a crazy bound. Top is 2x. Bottom is x e to the x squared. It's actually like not the worst integral to do. So we get 2 times 1/2 x squared is x squared. And then this is like almost perfect. 1/2. You do e to the, do u substitution on that if you're not sure where things came from. Natural log of 2. Okay. So I plug in the radical thing and square it. So I get natural log of 2 minus 1/2 e to the natural log of 2. E to the natural log of 2 is just 2. Minus, plug in 0, you get 0 minus 1/2 e to the 0 is 1, so minus 1/2. Wow, so this is the natural log of 2 minus 2 times 1/2 is 1, and then plus 1/2. Do you get the natural log of 2 minus 1/2? That's one for the calculator to check. I think that might be what you get. So a couple of leaps that I made there. I integrated this. I did u substitution. U is equal to x squared, or u is equal to e to the x squared. Both of those are going to work. We had to have the intuition that here, when we took our square root, because we're not really dealing with 2x, we only need the positive square root. And then properties of logs came in. E to the natural log of blah is blah. Let's see what the calculator says. I think it's right. I'm gonna declare that right now. I think we got this right. It seems like it'd be a small region. I don't know. Integral of 2x. Well, let's do 2. I think if I put in the absolute value of x, it might make it like too hard for the calculator to get the exact value. Maybe. From 0 to the square root of the natural log of 2. Crazy. Yes. Look at that. Got it. Let's see what it actually looks like. Graph. So 2 absolute value of x. X times e to the x squared. Not like so far off. I definitely got the right-hand side better than the left-hand side if your graph looks like mine. But anyway, we got it. Woo! Can the calculator do this one? I don't know. I mean, we were a little thrown off last time. 0, and then I think I have to do like 0 plus the square root of the natural log of 2. It gets a value. Yeah, that's definitely right. So good job, calculator. We never doubted you. We always thought you would be able to do it, and it turns out you could. All right, let's do one more here. You got to practice. Like here, what is on top? 3 over x or that? I don't know. I don't know which of these is on top. Also, I have no clue. I don't have a clue in the world what that one graph looks like. So do I know where they intersect even? Can I even find it? The x's will cancel. And then maybe I'm gonna try to do it by hand. This seems like a really good place to just straight up use your calculator, but I'm not gonna do it. So 3 over x equals 1 over x root 1 minus natural log of x squared. So that's gonna be, what am I doing? So 3 root 1 minus natural log of x squared equals 1. Kind of like cross multiply. The x's cancel. X can't be 0, but the x's cancel. And you get that. All right, square both sides. 9 times the quantity 1 minus natural log of x squared is 1. 1/9. Okay, so 1 minus the natural log of x squared is 1/9. So then subtract, you get negative 8/9, but then, so the natural log of x squared is 8/9. So the natural log of x is plus or minus radical 8/9, or x is e to the plus or minus radical 8/9. Potentially, I don't know. I'm gonna go with it. I mean, I think that's right. So those are my bounds. I don't know which curve is on top. I tend to think 3 over x, because x times something else, like, so this is, but then it's like 1 minus something, so is it getting smaller? Like 1 divided by something smaller than x, 3 divided by x. I want to say 3 over x is on top, but I'm just guessing. So I'm going to do the integral from e to the negative radical 8/9 to e to the radical 8/9. It's like, why are we even doing this problem? Don't know. 3 over x minus 1 over x root 1 minus natural log of x squared, holy cow, dx. All right, I say sort of confidently. So I think it's 3 natural log absolute value of x. That one I'm confident of. Minus, what is this? Oh, is this arc sine? I think it is. I think if you let u equal the natural log of x, then du is 1 over x, and it's du over the square root of 1 minus u squared. Holy cow. I think it's actually a perfect arc sine. It's a sine inverse of the natural log of x. I think so. I seem to have simplified here. All right, plug in. Okay, 3. The natural log of e to the radical 8/3 is just radical 8/3 minus, so this will be the sine inverse of radical 8/3 for the same, like, e to the natural log of e to the blah is blah reason. And then here, so there's that absolute value. What does the absolute value do? I mean, that's a positive number, so it doesn't actually do anything. E, I don't think it does anything. I think it's just 3 negative root 8 over 3. And then minus sine inverse of negative root 8 over 3. Sine inverse is actually an odd function, like an odd function. So like the sine inverse of negative blah is negative sine inverse of blah, which means that's a triple negative. So 3, I think we get potentially 2 root 8 by combining this, that's just root 8, and then minus negative root 8 is 2 root 8. And then we have negative sine inverse of this minus negative is positive, so minus. So I think minus 2. I'm going to feel really good if this is right. And then the real question, so 2 root 8 is definitely bigger than 2 times the sine inverse of anything, right? Because the range of sine inverse is negative pi over 2 to pi over 2. So that would be pi 3.14 versus 4 times 1.4. Yeah, I think we got it right. All right, here we go. What are we gonna do? This is longer than I intended, but this is like a pretty challenging problem. All right, solve 3 over x. A lot of it hinges on this. 1 over x times the square root of 1 minus natural log of x squared. Yeah, x. 2. Okay, so far so good, I think. Integral 3 over x minus 1 over x times square root of 1 minus, why am I not just copying? I don't know. Squared, comma x from, okay, so the smaller one is the smaller one is the one with the negative, but like I never even thought about that. I was just like, yep, that one. Negative square root of 8 over 9. I'm going to put in what we like did, except I'm going to screw it up. And then the upper bound is e to the square root of 8 over 9. Cosine inverse? What are you even doing? What's the numerical value? 3 point whatever. 2 square root of 8 minus 2 arcsine of square root of 8. Nope. Of 8 over 3. It's kind of a moment of truth type thing. Yes. We got it. All right. Holy cow. All right, we're done with this. Thank God. We got them though. These are challenging problems. These are not standard, basic problems. We go big or we go home. All right, so we are done with this page. I will be back in the next video to do more with you. Take another look at these if you think you need to. Maybe find some practice problems that are a little bit easier than these last two for sure. So don't lose sight of that one. That first one we did, very, very common problem. All right, so see you in the next video.